All right. Thank you everyone for joining. I understand we're live. Apologies, we had some technical issues on our end, but we're ready to get started. My name is Kurt Kipka. I'm the Chief Impact Officer at Apparel Impact Institute. I'm joined today by my colleagues and partners, Leonie, Phil, and Michael, all of which are going to provide their perspectives and expertise in today's content. On behalf of AII, I just want to say one more time, thank you for joining. We're really excited to kick off this consultation period for the carbon and energy benchmark. And as the executive sponsor for this project, I am particularly excited about the prospects of this tool to do something for the industry that hasn't been done to date, and that is provide a quantitative performance indicator for the textile sector that ultimately we can build sourcing decisions, we can build emphasis and funding and programs around. And I'm particularly excited to see where this tool and the processes surrounding it go. With that, Leonie, I'll hand it over to you to provide us with an intro and then subsequently Phil. Thank you.
Yeah, thanks very much, Kurt, for the intro, and thanks everyone for joining this webinar. So I'll jump on presenting those slides in kind of like instead of Michael. So whenever he comes online, I think he can continue. But what we have planned for today is that we wanted to first run through the context and objectives of the benchmark project. Then Phil is going to jump in and provide for about half an hour the details on the benchmark, sort of giving a technical introduction to it. And then we have time for about 20 minutes for Q&A and any feedback that you would like to share that we're very happy to receive from all of you. So I've seen that Michael just joined us. So while I've started with the slides and just actually started with the agenda, Michael, if you want to continue, I can just continue with the slides. I'm glad it worked out now to have you join.
Indeed. Happy to jump in, Leonie. Just let me know. I'm ready.
Yep, whenever you want.
Okay,
I can hand over to you.
great. Okay, please advance. Okay, so thanks everyone for joining, and apologies for being a few minutes late, some technical issues, but if you've read the benchmark methodology document that was sent out, you know some of this background context that we see a growing number of companies setting science-based targets and taking action to reduce emissions. And we also know that a number of brands and organizations are developing their own benchmarks to evaluate performance. And so the intent here is to avoid misalignment and avoid creating additional burden for manufacturers, which is critical to this. So there's a need to create a unified and aligned benchmark for companies to evaluate what good looks like in terms of energy and greenhouse gas emissions. So hopefully companies will then focus on reducing emissions as opposed to deciding who has the better benchmark. So we put up the objectives of the benchmark on this slide, that we're trying to provide a consistent and credible way to measure performance, with the goal to enable facility to facility comparisons, instead of just individual facility percentage reductions, which companies are doing today. We also want to provide a way for companies to have a tailored approach to evaluating specific facilities based on what's actually being produced in the facility, so that you're not comparing a facility that makes one product versus a facility that makes a very different product. So providing that tailored approach. This is meant to be a tool for manufacturers to understand where can they find operational improvements, where should they invest their money. We know that manufacturers are reducing emissions, but this is meant to be a tool to support them. It's also meant to support brands to identify and place orders and direct business to better performing suppliers over time as this gets adopted. And for both, as I've mentioned, prioritizing intervention. So where do you intervene for low and high performing facilities? So those are the objectives. Next slide, Leonie. Here's the timeline. So just know that this has been a process that's been ongoing for some time. We've had a few different touch points already with stakeholders to get input. And we've had a technical review committee that's been involved from the start. And this is a draft, right? So we're looking for feedback from stakeholders, including those on this call. And as we look towards a final benchmark tool publication in January, we'll take feedback from this call, from another call we'll have next week, as well as written feedback to roll out a draft in January of 2026. I think importantly, and Phil might talk to this, once we put this out in January, it's not done per se. Like we're constantly refine this over time as we're getting better data, as factories are testing this. So this is meant to be a work in progress over time, but we will put out a final version in January for use. Next slide, please, Leonie. Just a word of thanks to these folks that have provided input from a technical perspective over the past number of months. I won't read through names, but just know that this group has been a mix of manufacturers, brands, other organizations that you can see on the screen that are deep experts in this space. So we really appreciate their time and their technical expertise in this process. As I mentioned, this is a draft. We are taking feedback on this call and one more call next week. There's a survey. There's the ability to send feedback by email, and we'll be compiling and incorporating this feedback between December and January to roll out the final benchmark. So really appreciate your participation here. It's probably been mentioned that we'll be taking questions as Phil presents coming up in a moment, but please feel free to share questions and comments through the Q&A feature as we go through this. But if you have additional comments, you can use that email address and send feedback, and that would be greatly appreciated. So Leonie, I think that's it for the context. And then I'm going to pass it to Phil. So Phil's going to walk through more of the technical side of the benchmark. And again, if you have questions, comments as we go through, please put them in the Q&A feature. So Phil, over to you.
Thank you very much, Michael. That's me. Thank you very much. Next, please, Leonie. Okay, so just looking at a simple analogy here, who is the better runner? The one on the left that's reduced their time by 30% in the last 12 months, or runner B who's reduced their time by 3% in the last 12 months? Which one is better? Which do you think? Next, Leonie. Well, of course, it depends where they started from. It's not all about the improvement. It's where they are now. It's where they've come from. Here, who's the better runner? The one on the left who's completed a race in 1 hour 55, or the one on the right who's completed a race in 2 hours 5 minutes? Next, please, Leonie. Of course, who said they ran the same race? It depends on the distance of the race. Next click, please, Leonie. Well, if on the left the person has carried out a half marathon in 1 hour 55, that's okay. It's quite good. But a full marathon in 2 hours 5 minutes is absolutely world class. The one on the right is the better runner. But just looking at parts of information only gives you part of the picture. Next, please, Leonie. So when we start looking at this in benchmarking terms, we can see that for an average social runner, they're sort of okay. They're at that okay level, but the world-class elite runner is absolutely as good as you can get virtually. And this is what we're looking at with benchmarking. We're not just looking about how fast they are. We're looking about how good they are. Next, please, Leonie. So when you look at who wins the, did you flick through to that, Leonie? If you look at who wins the medals, despite a 3% year-on-year improvement, it's the world-class marathon runner. Next, please, Leonie. But then importantly, who's got the most potential for further improvement? That is a key thing just to keep in your mind. Who's got the potential to deliver most improvement? Next, please, Leonie. So when we look at this in factory terms, we've got a lot of work going on at the moment. Excellent work by brands, by multi-stakeholder initiatives, by industry itself that is trying to reduce things year on year. And you may know the percentage reductions. You may know how they've reduced that over time. But it's very rare people know where they started And it's very rare that this is actually linked to the processes that are carried out within a facility. So what is good performance? What is okay performance? What is poor performance? And crucially, is there room for further improvement? Now, what you find in facilities, there are a lot of facilities who are very good, and they've got limited potential to improve. They've got to spend more and more to deliver lower and lower savings. But if somebody's a poor performing facility, there's lots of low hanging fruit there, and they can make massive changes very easily, very low cost, and that can deliver savings that helps people meet their targets, helps those facilities themselves improve, help them make money. And by being able to judge a facility, and I use the word judge, I don't mean that being judgmental, being able to assess the performance of a facility and say, are they okay, good, poor? It helps us unlock a lot more information, and so that we can prioritize interventions. Next, please, Filoni. So how does the AII benchmark work? Well, it's a two-stage process. The first process is to create a tailored energy and emissions benchmark for that facility. So each facility will have a different benchmark depending on the products and processes that are related to that facility. It's not a simple level 1, level 2, level 3 with simplicity. It is tailored so that we have a fair benchmark for each process, for each facility, depending on the process that they carry out. And then the second stage is we appraise the facility performance against those benchmarks. Next, please, Leonie. So in terms of creating the AII benchmark, what we need to create them is all we need are the production volumes and details of the products and processes carried out on site. That's all we need, and we create a fair benchmark based on that. Now, we've created the benchmark calculators, which you've now got access to those trial benchmark calculators. It is being digitized by Made2Flow, so that there's going to be a lovely user interface coming through for the actual launch version in the new year. But what we do with the benchmark calculators is we create a weighted average for that facility based on the products and processes carried out. Next, please, Leonie. So in terms of a facility, if you've got a simple facility that carries out process I, J, and K, and we've got an energy intensity associated with those processes, that we've got the example figures here of 10, 18, and 14 kilowatt hours per kg. We've got the volumes of each process that are carried out per annum. And then what we can do is we can create a weighted average energy target. So at the top on the right-hand side, we've got that energy target of 15.14 kilowatt hours per kg. That can be converted into an emissions target, a global average emissions target. This is just a placeholder figure. We're refining these figures as we speak to get them more accurate in terms of the emissions. But we will apply a conversion factor for grams of CO2 per kilowatt hour to create that emissions target. And that will be the figure for that particular facility. And that's calculated by just entering in processes IJK and the tons per annum. That's a very simple thing for the user to do. Next, please, Leonie. Now, the metrics from the calculators, the key two metrics are the weighted average emissions, because that's what we're interested in, reducing emissions and measuring emissions and assessing emissions associated with the particular processes and products. And then we've got the weighted average energy benchmark. Those are the two key ones. But we've also got a calculator for megajoules as well, which is just a conversion, but we split it into thermal and electrical. We also look at electrical use, which takes into account renewable energy, and then we look at the emissions associated with the thermal energy and the emissions associated with electrical. So we get a dashboard of information that can be used by the facility to identify opportunities to improve, and they can get a better picture of their facility. Next, please, Leonie. Now, in terms of vertical facilities, we've got two options. This is the first one where we get a single black box figure for the weighted average energy target and a black box figure for the weighted average emissions target. So we can actually do that by getting information on the production volumes, and we can appraise a facility and say whether they are meeting that benchmark for that overall facility. What this does do, though, it gives you a single figure. And if you're a vertical facility and you've got world-class spinning and terrible dyeing, your overall figure may look like an average figure and think, yeah, we're okay. And actually, if you drill down more, you will see that you've got work to do in your dyeing department. So this is something which you can do, but I would suggest and recommend that the more detailed approach is adopted if you can. Next slide, please, Leonie. So what this does is this creates individual benchmarks and targets for individual tiers within a vertical facility. It's just a little bit more complicated to do. And in terms of appraisal, we would need a little bit more information from within the facility. But I would recommend that facilities use this approach because it is quite common for people to have in a multi-tier facility to have excellence in one area and sort of okayness in another and poorness in another. And it just gives you that fuller picture. Next, please, Leonie. So in terms of the assessment, we've created via the benchmark calculators a benchmark target for energy, for emissions, and the split between thermal and electrical. To appraise a facility, all we need is details of the production types and volumes, and we need the on-site fuel use and steam purchases, and details of the grid electricity and on-site renewables. So essentially, it's production, it's fuel, it's purchased steam, purchased electricity, and any renewables. It's not massively complicated. This is information that people are typically collecting for their own use in a good facility, so that they're monitoring things just to manage their own processes. And other schemes are asking for this information. We just apply it in a slightly more nuanced way, in a slightly more sophisticated way with the benchmarks to give better information back. And what we would also recommend is what we call the utility map, which is that extra bit of data which shows where steam, fuel, water, compressed air are used throughout a facility, so that we can attribute energy and emissions to an individual tier within a vertical facility. And that enables us to do that tier by tier analysis. Next, please, Leonie. Now, in terms of the energy intensity versus emissions factors, energy use is in the hands of the facility, and it's a measure of their eco-efficiency performance. Largely, that is the case. So that if you use more fuel to power your boiler, or use more fuel to power your genset, or you've got lots of things that you do wrong and you have to make corrections, or you've got underloaded machines, or you've got leaks, etc. These are things that a facility can manage. And that is something which is universal across the globe. It doesn't matter whether you are at the North Pole, in the Pacific, or in the middle of Africa, the energy use metric will be the same. Emissions is slightly different because the emissions per kilowatt hour depends on the fuel type, and it's only partially in the hands of the facility because fuel choice may be limited. If you may be in a certain part of the world where, yes, you might want to use gas, but there's no available. You may want to use renewable certified biomass, but it's not available. Coal might be the only option. And then also the grid from which you buy electricity, the cleanliness of that, whether it's coal powered, whether it's nuclear powered, whether it's gas powered, it's largely out of the hands of the facility. So those emissions per kilowatt hour are largely out of the hands of the facility. They can make choices so that they have renewables, they can make some fuel switches on occasions, but it's not all in their hands. So what we've got is a situation where emissions are influenced by both the facility and external factors. So when we're looking at those benchmark figures, we will give a global energy figure, we will give a global average emissions figure, but one thing we are working on as well are regional emissions figures so that a facility can see where their performance is relative to the expected performance in that region. So if you're in a region where it's a coal-powered grid and you've only got access to coal, we would expect the emissions to be higher than in a facility where they've got access to a clean grid and gas, for example. So we need to be fair and reasonable, but we are clearly looking at a global issue with climate change, and emissions are emissions. So that's why we're doing both the global and the regional. Next, please, Leonie. Now, in terms of how a facility or a brand looking at a facility appraisal would look at this, you may look at that dashboard figure and say, look, this is a typical facility with an on-site coal boiler and an average cleanliness grid. What would we expect for a typical facility? Well, we'd expect the average emissions to be a little bit worse than average because you've got the coal on site. So that would make things, something out of your hands to a large extent. The energy would expect to be okay and meeting the benchmarks. In terms of the thermal energy indicator, we'd expect that to be okay. We'd expect the electrical energy indicator in terms of energy use to be okay. But then when we look at the emissions, the thermal energy indicator would be the big red flag because of coal boiler. That the emissions from the use of coal, they would be flagged as red. And then in terms of the emissions from the grid, those would be okay. So this is the sort of dashboard type information that people can be expected to get. And it's not a red, when I say a red flag, it's not a red flag, danger, whatever. It's just highlighting areas for priority action. Next, please. So when we start looking at looking at facilities and trying to compare one facility with the next, we've got a situation here where we've got two facilities that are both using 12 kilowatt hours per kg. One's reduced 30% to 12 kilowatt hours to kg. One's reduced by 5% to 12 kilowatt hours per kg. So they're both, to some extent, performing the same if we're looking at just energy. Dye House A is performing better because it's made better reductions, or is it? When you actually look at the processes that are being carried out, the first is a dye house where they're dyeing acrylic yarn, they're dyeing cotton yarn and polyester yarn, and then the second facility is a printer where they're printing viscose with dyes, they're printing viscose with pigments, and they're also doing some pigment printing with digital. Dye House A's got an on-site gas boiler, an on-site gas genset, and the total production is 3,000 tonnes per year. And they've got an off-site ETP, central or municipal ETP. The printer has got a coal boiler, on-site diesel genset, and a total production of 2,500 per year. So when we're looking at those and saying, well, which is the better one? It's really difficult to see. But with benchmarking, we can see it reasonably clearly. Next slide, please, Leonie. So when we look at Dye House A, the acrylic dyeing is a low intensity process. You can see if hopefully your font is big enough, 6.5 kilowatt hours per kg. Cotton yarn is higher at 13.57 kilowatt hours per kg, and the polyester is 8.94. And that gives a weighted average energy target of 10.69. So Dye House A is not meeting its energy target at 12 kilowatt hours per kg. It's over in terms of energy use, but because it's got gas as the fuel, it's actually meeting its emissions targets. So this gives us that granularity to say, well, where do you work on these? What do we need to work on here? Clearly, it's going to be energy efficiency. Next, please, Leonie. Now, printer B doing printing processes which are inherently higher energy intensity than some dyeing processes. So we can see here viscose reactive dyeing is 15.31 kilowatt hours per kg. Viscose pigment is lower energy at 12.85, and similarly for the digital. So their actual weighted average energy benchmark is 13.22. So here the performance of 12 kilowatt hours per kg beats that performance it beats the benchmark for energy use. But because it's got coal as the fuel and diesel as the fuel for the genset, it's not meeting its average its benchmark emissions. Now, in due course, when we build in regional benchmark figures, that may be meeting the regional expectations, but from a global perspective, it isn't doing that. So benchmarking allows us to compare different facilities with very different products and processes, and fairly and completely objectively say which is performing the better and identify opportunities for improvement. Next, please, Leonie. So in terms of which is better, DIASA is underperforming on energy, it's overperforming on emissions. You can see the 7,000 tons of emissions, and the action there will be to improve their energy efficiency. So even though they are doing okay on emissions, there's clearly an opportunity to improve, and if they got their energy efficiency performs better, they would further improve their emissions. Printer-B is overperforming on energy, and in terms of the detail, they're overperforming on thermal but underperforming on electrical, but they're underperforming on global emissions. So the action here would be improve energy efficiency further, because that's going to help with emissions, and then they'd need to be looking at either fuel switches, PPAs, renewable energy on site in order to get that emissions figure down. Next, please, Leonie. Now, in terms of what have we got in the databases? We've got the typical energy intensity for all model production processes. This is particularly for the wet processing. And the reason why we use model production processes is because there are no two facilities that are identical. We've got to create the model processes, so we pull everything back to a consistent starting point. So we've got the energy intensities for those model processes, we've got the electrical and thermal split, and also additionally we've got the energy use. In terms of emissions, we've got the emission split for electrical and thermal, and then also we've got some correction factors. So we've got the base correction, benchmark calculator, and then if somebody's got an effluent treatment plant on site or zero liquid discharge where they're recycling all the water, we allow a correction factor. So they are going to be using more energy, and it's only fair that we build that into the benchmark calculation. Similarly with spinning, if somebody is doing twisting or covering or something after a basic spinning process, it's only fair that that energy is factored into the benchmark calculator. Now you've got access to the tools, you can see what's in there, and we appreciate feedback on that over the coming weeks. Next, please, Leonie. So in terms of how did we create the database? Now the wet processing database, I've been heavily involved in that, and it's based on a combination of primary data, so data from facilities that looks at the total amount of energy used to power the boilers and the gensets, to power the processors. We've also got some information on process demand, which is helpful, but we need to tie everything back to the energy content of fuel, because when we burn that fuel, we get the emissions, and that's what we're interested in reducing. We've also used some modeling software to fill in gaps where no primary data exists, because when we try to find data from single process facilities, it's very, very rare. Most facilities are mixed, and it's difficult to untangle that data. We have some, but not much. So we've used modeling software to fill those gaps. And you can see I'm an old man. I've been in the industry a long time. I've been working alongside Jimmy Summers and Siva Pariti, who also have lots and lots of experience. And if we've got some figures where we think we know that that is bigger than this, but it's not quite right, we've made some adjustments just using our combined 100 years probably of experience in the industry. And we think we've got something on wet processing which is very, very good, and it's being tested at the moment, and we'll be reviewing the data as it comes back. Now, in terms of the dry processes, Made to Flow, who work very closely with Parallel Impact Institute, they've got data from 12,000 facilities. They have got, I think, 56 countries. And Atniel from Made to Flow and his team have done a statistical analysis of this data. And they have much bigger brains than me. And they've created the data for the benchmark calculators for garment making, for spinning, for knitting and weaving based on this data analysis from primary data. So they're made slightly differently, the wet processing and the dry processing, but there's full transparency on how we've done that on the methodology documents which you've got access to. Next, please, Leonie. I think that's it. Yes. Hopefully that's clear, but happy to take questions now. Happy to take questions offline.
Excellent.
Perfect.
So, Phil, thank you, Phil. That's fantastic. So, Phil, a couple of questions have come in, and I'll kind of read them off. But for folks on the line, please add other questions. We've got plenty of time to take your questions. So, Phil, the first question that came in from Fiona Barrett, is the intention for the weighted average to allow for the creation of an overall global standard?
Well, the intention here is obviously, as I mentioned, to create tailored standards, tailored benchmarks, sorry, for individual facilities. So because, as you saw with those examples of the dyer and the printer, the different processes have got different energy intensities. We have to create that tailored target in order for this to be fair. And this is learning from the Inditex Care for Water program, which I developed with them a few years ago, where we create water targets based on the processes that are carried out on site. And that's worked very well for them. And the reason it works well is it is seen as fair. Now, in terms of a global standard, our intention is over time that this will develop into a sort of a foundational limit where below that you seem to be not performing very well, an entry level, an okay level, and then a level that can be seen as being excellent. But we need to get more data in before we assign those limits. But they will be a sort of a global level of stringency rather than a single standard, because we have to have the tailored benchmark for the individual facilities. I hope that's clear.
Okay, this was from an anonymous attendee, and this is something that's come up through the process. We've got input from the TRC on what's the level of effort for factories to evaluate and enter the input values, and more specifically, do they already have the knowledge, for example, on the tons per year, and energy intensity per process? And if they don't have this, how much work is it going to take to get this information, Phil?
Firstly, in terms of the production volumes, good facilities have this. It's just an everyday measure. Poor facilities may not have this, but I think as we roll this out, it will be clear that people have got to have this information going forward. This isn't the only scheme that is asking for that sort of information. In terms of the energy intensity per process, they don't need to have that. All they need to have is the overall fuel situation and the grid electricity and renewables information. They don't need to know the intensity of individual processes. That's all. We've done all that hard work with the benchmark calculator.
Great. Excellent. I'm seeing more questions come in, so thank you, everyone. So next, Farid Abed, if I'm pronouncing that right, can we get a certificate, Energy Management System ISO 5001 by these rules? We've not really talked too much behind the scenes about that, but yeah, Phil, what about ISO 5001? Yeah.
I mean, I don't think having your facility benchmark using this process would qualify you for any ISO certification. However, I can't imagine that you would get an ISO certification for energy management if you didn't have the sort of information we are asking for in terms of energy use, fuel use, and production volumes.
Yeah. Okay, great. I see two questions coming in from Kevin Mayette. Thank you, Kevin. First is, how are we feeling about the level of granularity regarding the processes and sub-processes that we've arrived for this work? And then do the processes align with other initiatives, the MSI, the wet processing initiative, and how do we get feedback from these entities? Or is it pretty well set? So I'll give that question and I'll come back to his second question. So,
Um, as Michael said, that this isn't cast in stone. So this is a live tool. We think it will be live forever, so that we will refine it. We will look at data, and it will be reviewed, possibly annually, possibly more frequently than that, and it will be changed as we get good data and good feedback. So this isn't it's always going to be the same. In terms of the processes and sub-processes, we think we've got probably 98% of processes covered. But if somebody came to us and said, look, I want my factory session and we've got a Mohair Lurex blend, and we need to have something developed for that, aligning the calculator, we will do that. Or we will guide them towards an equivalent. So it will always be live. And again, we're learning from the Inditex Care for Water program, where when that was launched, it was always live and it's reviewed. Things have been added, things have been changed, and that's appropriate.
Yeah, great. And then the second question from Kevin, and this might be answered by Kurt if you'd like, or Phil, but have we considered how this benchmark could be misused, thinking primarily by brands? And if so, what measures have we put in place to minimize this risk? This is obviously a topic we've talked a lot about. Kurt, do you want to put you on the spot? Do you want to chime in on that? And then anyone else can chime in as well.
Yeah, ultimately, it starts with terms of use, which we've already embedded into this process. We do expect that this tool is going to be deployed and will be used for further conversations about prioritization and focus, which I think will support brand or more sophisticated brand conversations with suppliers. But in the event that it's misused, that's where our terms of reference come into play. We will, along with the methodology document at the beginning of the year, provide guidelines and expectations around how the tool can be used. And ultimately, it's our intention that this is a highly supplier-centric process. And an ideal world is where a supplier can share such a benchmark performance with a brand so as to have a more candid and direct discussion with that brand versus a target being inflicted or a goal being inflicted upon that supplier. It's a much more tailored process.
Yeah.
And I think one thing I'd say on this is that we want this tool to be available to anybody who wants to use it. So if a facility, if they want to access it and use it for self-appraisal, we would absolutely encourage that. We wouldn't want a facility to get a knock on the door and be surprised by a brand saying, I'm going to check you out with this tomorrow. So facilities should be using it to see where they sit in terms of their performance, to look at the granularity of that dashboard information and see where they can improve. So we do not want this to be used by brands to beat up suppliers at all. It's a tool for everyone. But the sooner the industry can get their hands on it and self-appraise, the better.
Yeah, great. There's a question about whether the primary data connected to the synthetic fibers, and does this include cellulosic? And is there any data that tells us if one or the other are more environmentally friendly? I'll just say that this tool covers all fiber types, and again, it's looking at manufacturing processes, which covers all fiber types. And there are other tools and data sources that tell you the relative environmental impacts of poly versus cotton versus nylon versus others, right? MSI. and other organizations. But the benchmark tool is looking at, wet processing of all fiber types, not just synthetic, not just cellulosic.
And it's representative of typical processes.
Yeah.
So what we're doing here is, as I mentioned earlier, the energy intensity of dyeing acrylic is very low compared to dyeing cotton. So we will assess somebody against a typical acrylic process, not versus cotton. If you want to, overall,
Yeah.
it tends to take less energy for processing synthetics than the natural fibers. But we're fiber agnostic. We're just looking at what happens in industry. We're not promoting one or the other. We're giving fair comparisons.
These are great questions, so please keep them coming. What are the databases and sources used to create the regional baseline used to compare with facilities and processes numbers? Phil, I know we talked a little bit about this, but maybe talk more about the data sources.
Yeah, I mean, in terms of the regional benchmarks are on emissions. So what we are looking at there is we're looking at the fuel types used on site, and we've got some really great information from Worldly on this from their database about which fuels are used in which quantities in different countries. We've only got a selection of countries at the minute, and that will be expanded for launch. And then also we'll be looking at the grid emission factors with the intention of that being IEA information.
Great. A somewhat related question from Joyce from Cascal. And Joyce, thank you for staying up late for this. How did you come up with the weighted average factors? And again,
well, the weighted average is just a simple way of saying if you've got a process that has got an energy intensity of 20 kilowatt hours per kg, and you've got another process that has got an energy intensity of 10 kilowatt hours per kg, then if it was a 50-50 split, the benchmark would be 15 kilowatt hours per kg for the factory. If it was 75-25, it would be 17.5 as the benchmark. So it's just a way of calculating a fair target based on the products and processes that are carried out on site.
Great. A question, do you reflect the individual loss producing thermal energy on site compared to your benchmark energy data from your database for specific processes?
The energy intensity for specific processes are based on the energy content of fuel required to power that process, not on the process demand. So if you take a typical dyeing process, let's say it requires 10 kilowatt hours per kg in terms of energy content of fuel, so the gas going into the boiler or the diesel going into the genset, it's likely to have a process demand of about 5 kilowatt hours per kg. So that we've got losses from the boilers and from the genset. So boilers are typically around 75% efficient, gensets 33% efficient, and we've also got a figure in there for sort of real life issues like underloading of machines or getting things wrong and having to do corrections. We've also got a figure in there for ancillary processes like laboratories and warehouses and whatever. So it's what we call the real world figure of energy required to power that process.
Great. Thank you, Phil. A question about how do we validate the information entered by facilities?
Well, that's a good question, and we're currently at tool testing stage, and we've had our partners from Reset working with facilities. We've also had a couple of brands working with their with some of their suppliers. Ultimately, we would have, I imagine we will have a self-appraisal where the information will be provided and then validation of that. At the moment, because this is new for the facilities, we've had people going in and checking fuel bills, checking electricity bills, etc., etc. But it will be that type of validation. Now, of course, what people will also need to look at is validating the production volumes, because everything is based on kilowatt hours per kg or grams of CO2 per kg. So it's just as important to validate the production volumes as it is for the energy, because they're obviously codependent.
Great.
And I think
Um,
just to add to that, we currently have a pilot running with Made2Flow in a questionnaire, and through their platform, the data is validated through AI as well.
mhm. Great. We've got another question from Todd. Thank you, Todd. For the energy benchmark, is there any adjustment that we'll make for local weather and climatic conditions? For example, some facilities that are operating in colder or hotter climates, which may have an influence on how much energy is needed. For example, heating up water for dyeing or to dyeing temperatures. So any adjustments? That's tricky, but Phil, how do you factor that climatic weather?
Yeah, I mean, it's a great question, and it's sort of very much in the, I've put the advanced section
Yeah.
of thought process here. Siva, Jimmy, and I spoke about this and said, well, can we build it into the first prototype?
Yeah.
And we said, let's keep it simple at the moment. So we've used a notional entry temperature of 20 degrees for water. That's what we've used in our calculations. But I think what we'd need to look at is where those extremes are. So if somebody's got cold water at 8 degrees in winter, Todd's absolutely right that it's going to require more energy. Equally, if you're somewhere like Bangladesh where your water is going to be at 28 degrees all year round, do we make a harsh, if we moved it one way, we would need to move it the other. So it's a consideration, and we just need to see, how critical that is, and whether we build it into the, a revision process. It may be that we have a situation like we've got ETP of the correction factor. Maybe we have something like anything outside a delta of 5 degrees from our notional 20 degrees input, it needs to be inputted and there'll be a calculation change. So it can be done, but we've not done it at the moment. But great question.
Yeah. Yeah, great question. So we do have more time. If there are any other questions, I'll kind of just leave it open for a moment to see if we have any more questions that folks have. And Phil or Kurt, if there's anything else that you want to emphasize as we kind of wind down here. Or Leonie.
I'll just, for one more time, thank everyone for joining and participating. I'll let you wrap everything up, Michael, at the end. But just in terms of the questions that have been raised, I want to show gratitude for those questions as you've raised them, but also invite anyone with those questions and follow-up suggestions or comments to involve yourself in the process for stakeholder engagement, which will transpire from this point forward. And so, Kevin, to your great questions that you were asking, for example, how this might be misused, give us an indication of how it might be misused. And for other tendencies that we may have to take into consideration for this tool to be the most effective, please, we invite you to participate in this process and get involved in ensuring that it's as successful as possible as we head into the next year. With that, Michael, didn't mean to steal your thunder, so to speak.
No.
I'll let you wrap it up from here.
Yeah, no, that's good. And you can see on screen that there's a survey that you can provide feedback that way. There's an email address that you can send additional comments and questions to. And as we mentioned at the start, we're going to be taking feedback and publishing a revised benchmark in January of 2026. So that's it. Unless there are any other questions, we'll wrap up. Really appreciate the questions and the time from folks on the line. And Phil, thanks again for going through the detail on that.
Absolute pleasure. Thank you.
Okay. Thanks, everyone.